Hi guys, hi Maths Trig Expressions. We're going to look at related angles. We've just looked at exact values. Related angles ties in with that. So we've found out in the exact value video just before this how to find sine 30, sine 45, cos 60, tan of 60, cos of 45, etc. So we're going to use that knowledge along with some National 5 knowledge from our cast diagram here. And we're going to use that knowledge to find out things like sine of 120, cos of 240, tan of 315, and so on. Okay, so just a reminder about the cast diagram, which you should have covered in the essential skills. So the sine of anything between 90 and 180 is positive. That's why I've got sine plus here. So we normally just write ASTC, but sine is positive. And if we have a look at the graph, here's 90, here's 180. The curve is always above the x-axis there, so always getting a positive value. Cosine between 90 and 180 is always negative. The curve's always below the x-axis. And the tan of an angle between 90 and 180 is also negative. And in the other quadrants, well, in the first quadrant, all of sine, cosine, and tangent are positive. You can have a quick look at the graph there. It's always above the x-axis. In the third quadrant, only tan is positive. So between 180 and 270, sine's negative, cosine's negative, but tan is positive. And in the fourth quadrant, only cosine is positive. So as we can see here, sine is negative, cosine is positive, tan is negative. Okay, so we're going to use that along with the symmetry of the graph. So if I'm looking at the sine of 30 degrees here, that has a value of 0.5 or 1/2. So if I wanted the sine of 150, that is also a height of 1/2. So using the symmetry of the graph, the sine of 30 is just the same as the sine of 180 minus 30. Okay, so that's why we've got this 180 minus here. If I wanted the sine of 210, well, I know that's going to be negative, and I can write that as the sine of 180 plus 30, because I'm 30 degrees past 180 here. So the sine of 30 is 0.5. The sine of 210 is negative 0.5, which again, if I know that's 0.5 for the sine of 30, then I could use my cast diagram rather than sketching the graph here to find the sine of 210 as being negative 0.5. So let's have a look at one question where we do that. So here we're going to do the sine of 240 degrees. So looking at the graph here, there's a sine graph. So 240 degrees is 60 degrees past 180 degrees. So the sine of 240 is going to be the negative of the sine of, well, we were 60 degrees past 180, so the sine of 240 is the same as the negative sine of 60. Okay, so here we're moving 60 degrees along and looking at the height, which will be root 3 over 2, because we know from our exact values that the sine of 60 is root 3 over 2. Have a quick look back at the previous video if you've forgotten that. So the sine of 240 will be the negative sine of 60, because by going 60 degrees along from 180, we're traveling the same distance, so the graph will be a similar distance from the x-axis, but it'll be root 3 over 2 below the x-axis rather than root 3 over 2 above the x-axis. So an alternative way of doing that question, we draw a cast diagram, we count around from the positive direction of the x-axis, we go anti-clockwise 240 degrees, similar to what we were doing at National 5 when finding a second angle. So we go around 90, 180, plus 60, which is 240. Now that is in the third quadrant. Only tan is positive here, and I'm 60 degrees into that quadrant. So the sine of 240 is the negative sine of 60. Again, I know it's negative because only tan is positive in here. So it'll be the negative sine of 60, which is negative root 3 over 2.